Welcome to Eureka Math. I'm Mr. Schenkel. I'm helping you today with Algebra Module 1, Lesson 9. All right, the first thing we're going to do is multiply polynomials. And when we multiply polynomials, it is just a use of the distributive property. So I'm going to take this first term in my trinomial, 3x squared, and I'm going to multiply that by every term in my other trinomial and see what we get. So 3x squared times x to the fourth would be 3x to the sixth. When you multiply exponents, you simply add the exponents. So 2 plus 4 is 6. 3x squared times a negative 2x. Well, 3x squared times a negative 2. Negative 2 times 3 is a negative 6, so that's my coefficient. And then x squared times x is x to the third power. And then lastly, 3x squared times 1, well, that's just going to give me a positive 3x squared. And that's the first part, distributing the 3x squared. So I'm going to give myself some room here and now show you the second term, x, distributed to every term in the second trinomial. So x times x to the fourth would be a positive x to the fifth. X times a negative 2x would be a negative 2x squared. And x times 1 is a positive x. Okay, and then the last thing we need to do is to get rid of the last term in our trinomial, distribute that last term, and that's the negative 1. So negative 1 times x to the fourth is a negative 1x to the fourth. Negative 1 times negative 2 is a positive 2x, and a negative 1 times a positive 1 is a negative 1. And now that I've done all of that work, I can combine like terms. So the first thing I'm looking for is all of the x cubes, x to the sixth, and I only see one, so 3x to the sixth. That one's out of there. Next one is, based on degrees, is x to the fifth, and I don't see any other x to the fifths, so this is plus x to the fifth. That one's done. Next would be our x to the fourth, which is a negative x to the fourth. I don't see any other x to the fourth, so that's negative x to the fourth. That one's done. Next would be our x to the thirds. That is a negative 6x to the third, and that's the only one I see, so negative 6x to the third. That one's gone. Now I see a couple of different x squareds. I've got a positive 3x squared, I have a negative 2x squared, so 3 minus 2 is 1x squared, so a positive 1x squared. Okay, those are taken care of. Next I see an x, a positive x, and a positive 2x. So that is a positive 3x. And then the last thing is my constant. There's only one constant. It is a negative 1. So there it is. There's the polynomial using the distributive property. All right. Today we're going to undo all of that we just did. We're going to find the greatest common factor, and instead of multiplying a common factor into an expression, we're going to divide it out. So in essence, we're undoing what we usually do with the distributive property, which is multiply a number into an expression. This time we're going to take it out. So I'm going to take a look at both of these terms of my binomial, and I'm going to find out what the greatest common factor is. So I'm just going to make myself a reminder that I want the greatest common factor of these two terms, and then I'm going to divide it out of that binomial. So let's see, if I consider the coefficients first, I have a 6 and a 14. 6 doesn't go into 14, so the greatest common factor can't be 6. The next biggest factor of 6 is 3. Does 3 go into 14? No. The next biggest factor of 6 is a 2. Does 2 go into 14? Yes. So 2 has to be my greatest common factor. That's the coefficient part. And then I can see that there's an a in my first term, and there are 2 a's multiplied together in my second term. So they have a common a. 1a. So a to the first power, or just a. That is my greatest common factor. And then I'm going to divide out that greatest common factor from each term and put it back into my parentheses. So let's do that. For this first one, it's going to be 6a divided by 2a. And 6 divided by 2 is 3. A divided by a cancels out, so it's just 3. All right, my second term is 14a squared divided by my GCF, which is 2a. And 14 divided by 2, well, that's a positive 7. And up here I have 2 a's. Down below I just have 1. So one of these a's cancels out with one of those, and all I'm left with is a. So I get 2a times the quantity 3 plus 7a. All right, how do I know if I'm right? Well, I can use the distributive property again to multiply that 2a back into the expression and see if I get my original expression. Well, 2a times 3 is 6a, so that first term checks out, and then 2a times 7a would be 14a squared, and that second term checks out, so I know I factored that expression correctly. Okay, B, what's common? I've got a 2x to the 4th, I've got a 2x to the 5th, I have a 2x to the 10th, so my GCF is 2x to the 4th. Every term has a 2, and every term has at least 4 x's, so x to the 4th. That's my GCF. Then I'm going to fill in the parentheses by dividing. I'm going to take that first term, 2x to the 4th, and I'm going to divide it by my greatest common factor, which is 2x to the 4th. So my first term becomes a 1. Second term was a 2x to the 5th. I'm going to divide that by 2x to the 4th. The 2's cancel. 4 of the x's cancel, so I'm only left with a positive x. And then lastly, my last term is a 2x to the 10th, and I'm going to divide that by 2x to the 4th, and the 2's cancel, and 6 x's will be left up top. 4 will cancel out with 4 of these, and I get x to the 6th, so that's a positive x to the 6th. And that is my factored expression. I can check to be sure that this is correct by just reversing that process. 2x to the 4th times 1 is 2x to the 4th. 2x to the 4th times x is 2x to the 5th. And 2x to the 4th times x to the 6th is 2x to the 10th. So I know I factored it correctly. C. I need the GCF of 6 and 15. Well, 6 doesn't go into 15. The next biggest factor of 6 is a 3, and 3 does go into 15. So 3 is part of my GCF. Each of these terms have at least one z, so z is the other part. So 3z is my GCF. And then we can divide out our greatest common factor, so that would look like this, 6z squared divided by 3z. And 6 divided by 3 is 2, and z squared divided by z is z. There's my first term. And the next term is a negative 15z divided by my GCF, 3z. Negative 15 divided by 3 is a negative 5. And z divided by z is 1, so it's just negative 5. 3z times the quantity 2z minus 5. And if I'd like to check, 3z times 2z, that's 6z squared. And 3z times a negative 5 is a negative 15z. Good factoring. All right, D. I've got 3 terms now, a trinomial. I need the greatest common factor for all of those terms. Well, if I look at the coefficients 42, 14, and 77, it looks like 7 goes into all of those. 7 into 42 6 times, 7 into 14 2 times, 7 into 77 11 times. 7 is a GCF. They all also have a W. So that's my GCF, 7W. And then let's see what's left. 42W cubed divided by 7W. 42 divided by 7 is 6. W cubed divided by W is W squared. There's the first term. Second term is a negative 14W divided by 7W. Negative 14 divided by 7 is a negative 2. And W divided by W cancels, so it's just negative 2. Last term, 77W to the 5th divided by 7W gives us a positive 11. And W to the 5th divided by W is W to the 4th. All right, E. Well, I've already, let's see, I've got to put these together first. So let's look at E. I have z squared times a, so that's going to be a z squared. Z squared times b is going to be a positive b z squared plus z cubed times a, that's a z cubed, and z cubed times b is a positive b z cubed. All right, so I have a 4-term polynomial, and what I'm looking for is something that they all have in common, their greatest common factor. Well, the greatest common factor here, I can see that there's a z in this one, there's a z in that one, there's a z there, and there's a z there. In fact, there are z squareds in every one, at least z to the 2nd power in every one. So that is my GCF, z squared. GCF. Did I call it a ZCF? I hope I did. I don't know, but I hope I did. GCF, greatest common factor. All right, what's left in the parentheses? Well, I'm going to take the first term and I'm going to divide that by z squared. Those will cancel and I'm left with a. Second term, I'm going to divide that by z squared. Those cancel and I'm left with just a positive b. Third term, I'm going to divide by z squared. And, well, 2 of my z's will cancel. I'm going to be left with 1 and the a, so that's a plus a z. And the last one, I'm going to divide by z squared. Same thing, 2 of them cancel out. I'm left with bz, a positive bz. And there it is factored. All right, F. What's common between these two terms? Well, it looks like they both have a 1/2 in them. So I'm going to factor out a 1/2 and see what's left. So 3/2 divided by 1/2. In other words, how many 1/2 are in 3/2? That answer is 3. And s squared is still there. And then how many 1/2 are in 1/2? Well, that's 1, a positive 1. So I get that expression factored. 1/2 is my GCF. I'm left with 3s squared plus 1. G. Oh, lots going on. Well, is there something that I can take out of all of these? Well, let's first look at the coefficients. 15, -6, +9, +3 times a square root of 2. So that I could take a factor out there. And those are my 4 terms in this polynomial. So it looks like 3 is going to be a GCF. So I'm going to try to put that over here. 3. Well, maybe there's more. Let's see. P cubed in this one. P squared in this one. P to the 4th here. And a P cubed again. So there's at least a P squared in each one. So I'm going to take a P squared out of each one. What about the R's? There's a R to the 4th, R to the 5th, R squared, R to the 6th. They all have at least R squared in it. So R squared is also part of my GCF. All right, and I can see I'm going to need some more room here. Oops, that's not what I want to do. I'm going to move this a little bit so we've got some space. Okay, and now I'm just going to divide. Let me get rid of this. Just keep little housekeeping here. I'm going to divide that first term by 3 P squared R squared. So 15 divided by 3, 5. P cubed divided by P squared leaves me with P. And R to the 4th divided by R squared leaves me with R squared. Okay, that's my first term. That's my first term. Second term, let me change colors just so we can keep them straight. Second term is here. I'm going to divide that by 3P squared R squared. Well, -6 divided by 3 is a -2. P squared divided by P squared cancels out. And R to the 5th divided by R squared leaves me with R to the 3rd. Okay, there's my second term. Third term, I'm going to divide that by 3P squared R squared. And 9 divided by 3 is a +3. P to the 4th divided by P squared leaves me P squared. And R squared divided by R squared cancels, so that's it. That's my third term. Okay, fourth term, I'm also going to divide by 3 P squared R squared. And 3 divided by 3 is 1 times the square root of 2. So this is a positive square root of 2. P cubed divided by P squared is P. And R to the 6th divided by R squared is R to the 4th. And there it is. Oh, just ugly as can be, but it is factored. We've got the greatest common factor pulled out of every term. So it is factored. Distributive property. Okay. Next, looks like I can get a 0.4 out of each, and I can also get x to the 8th out of each. So that's a big GCF. Let's see what's left. 0.4 x to the 9th divided by 0.4 x to the 8th. Well, the 0.4's cancel, and I'm left with just x. Second term, I'm going to divide by 0.4 x to the 8th. So I've got a -40 divided by 0.4. -40 divided by 0.4 is 100. And it's negative, so that's a -100. The x to the 8ths cancel out, so that is my factored expression. Okay, a couple more. Well, before I can factor anything out, I need to simplify as much as possible. So for this one, I've got 4x times x squared. That is 4x to the 3rd. And then 4x times x to the third would be a positive 4x to the fourth. And then 3 times x squared, that's going to be a positive 3x squared. And 3 times x to the third is a positive 3x to the third. So there's the first one simplified. All right, and now I am going to change this is the opposite of 2x plus 2, so that would be a negative 2x minus 2. And then I'm going to distribute that negative 2x. So negative 2x times x squared would be a negative 2x cubed. Negative 2x times x cubed would be a negative 2x to the fourth. And then the negative 2 times x squared would be a negative 2x squared. And a negative 2 times x to the third would be a negative 2x to the third. Okay, now I can combine like terms. So if I look for all of the x to the fourths first, got 4x to the fourths. Here is a negative 2x to the fourths. So that leaves me with 2x to the fourths. I see a 4x to the third. I see 3x to the third. That's 7. Minus 2x to the third. That's back to 5x to the thirds. And then minus another 2x to the thirds, that's down to 3x to the third. So positive 3x to the thirds. What's next? I see an x squared. That's a positive 3 and a negative 2. That leaves me with a positive 1x squared. Now I can take out a common factor, and the common factor is x squared. So x squared, and then we're just going to see what's left after I divide by x squared. So let's do that. Divide the first term by x squared, and I get 2x squared. Divide the second term by x squared, and we get 3x. So positive 3x. And divide the last term by x squared, and x squared divided by x squared is 1. So there we are, factored. Okay, last one for today. I've got to do the same thing as I did above, so lots of numbers and variables coming, but here we go. 2z times z. Well, that's 2z squared. 2z times negative 2 is a negative 4z. 5 times z is a positive 5z. And 5 times negative 2 is a negative 10. So there's the first one. This negative means I need to change everything in here to its opposite. So positive 13 becomes negative 13. Negative 26 becomes positive 26. And now I can distribute. Negative 13z times z is a negative 13z squared. Negative 13z times negative 3 is a positive 39z. And then 26 times z is a positive 26z. And a 26 times a negative 3 would be a negative 78 constant. Okay, now we can combine like terms. And let's see, looks like squareds are the biggest degree I have. So 2z squared and a negative 13z squared. Well, that's going to be a negative 11z squared. Okay, and then I look for z's. I see a negative 4z and a positive 5z. That's a positive 1. Plus 39z, so that's up to 40. And then another positive 26, so that's 66z. Positive 66z z. And then for the constants, I see a negative 10 and a negative 78. That's a negative 88. All right. Well, what's in common? Looks like an 11. And that's it. So let's see what we've got if we take out an 11. Well, a negative 11 z squared divided by 11 is a negative z squared. Negative 1 z squared. 66 divided by 11 is a positive 6z. And a negative 88 divided by 11 is a negative 8. And there we have the factored expression. All right, that is lesson 9. I hope that helps. I'll see you again next time.